In this video, I'm going to show you and walk you through the answers and solutions to the additional projectile motion and forces questions as you get ready for our upcoming quiz. So you can see in this question, we've got a champagne cork being fired from the bottle, and it says the record for the horizontal distance is 53 meters. Remember, this is a projectile motion question, so it's important that we keep horizontal and vertical information separate. Now, it says it's from the ground at an angle of 40 degrees to the horizontal with a speed of 32 meters per second. You can see in my diagram here that I've marked my angle from the horizontal right here, and 32 meters per second is the total speed, so that is actually the hypotenuse here. Now, it asks for the vertical component. That's going to be this one here, and later on, I'll probably have to do the horizontal one as well. Now we can do this a couple of ways. We can realize that this side of the rectangle is exactly the same as this side. And that means compared to 40, I've got my opposite and hypotenuse. Or I could know that this is a 90-degree angle right here, so that this angle is 50, and I could find using trigonometry that way. I'm going to do the first method. So I have here then 40 degrees, and I'm going to be using opposite and hypotenuse, so that's sine. My opposite will be that vertical component. I'm just going to use the letter V, and over the hypotenuse, which is 32. Let's put a little actually subscript there for saying it's the speed in the vertical component. And then now, if I move that around, 32 sine 40, pick up my calculator, and you should get a value of 20 point, let's round it to one decimal place here, 20.6. Don't forget, you should have your calculator in degrees for that. All right, that's part A. Part B, let's calculate the time it takes for the cork to reach its maximum height. Now again, we need to make sure that we are keeping our vertical data separate from our horizontal. And in the vertical direction, it's going to accelerate. So, Subat. So let's go ahead and put our values in. We know that its initial speed vertically is going to be 20.6 meters per second, and that's going to be positive because it's going upwards. The next part, what else do we know? Acceleration, negative 9.81 meters per second squared. And what else do we know? At its maximum height, it stops. So that means V equals 0. What am I looking for? I'm looking for the time. So let's put a question mark there. This is really important that you write down the given information and then go and write down what you know. We should have 4 pieces that have something beside it. That's why I say put the question mark as well. 3 pieces of numbers and a question mark means I can find the question mark. So now I need the equation that has A, V, U, and T. All the equations will be given to you on the quiz. Here it is here. Now V is 0. We like that because then right away I can cancel that out and it makes my algebra so much easier. If I now rearrange this for T, T is going to be negative U over A. When I put the numbers in, I'm going to get negative of 20.6 over negative 9.81. I'm going to get a value of 2.1 seconds. So that will be the time it takes from when it's being released, and we're going to assume it's being released from the ground up into the air and reaching its maximum height. So part B, well actually it's the second B, I don't know why I don't have a C, but anyway, says calculate the horizontal distance traveled by the cork through the air. Now what I want you to think about is it takes 2.1 seconds to get up to the top, and then it's going to take another 2 seconds to come right back down again. Now, I know I was saying about making sure you keep your horizontal and your vertical information separate, but time is the one that's exactly the same in both directions because it's a scalar. Okay, so it wants us to know the total distance traveled. So I know that it's going to be 4.2 seconds horizontally. And horizontally, we have a constant speed because we're ignoring air resistance. So that means I'm going to use the equation V equals D over T. All right, so we just found what the time was. The distance is what we're looking for. So I'm going to need, before I do anything else, I need the horizontal speed. Now, if we take a look over here, remember where I said I was going to have to calculate this again. If we had the vertical component is 32 sine 40, that means my horizontal component is going to be 32 cos 40. Here's 40. I'm looking for the horizontal component. That's adjacent and hypotenuse, which is cos. Okay, so constant speed, V equals D over T, rearrange for D. It's going to be my speed, 32 cos 40 times my 4.2 seconds. And you should get a value of 103. Now, it said that the world record was actually 53 meters. We have a value well larger than 53. And so question D says, suggest an explanation. Well, a couple of things. One, we really did ignore air resistance. And, over that long of a distance for that much time, not very likely. Even though the cork, maybe if it's just falling a meter or two, probably isn't going to have a lot of air resistance. We know that the faster you move, the greater the air resistance. So in this case, once it goes at that speed, we should not neglect air resistance. And so here's my written answer. So in this case, we have a archer fish in the water, and he's going to spit water at the grasshopper to knock him off the leaf. So we know that it has a speed of 0.35 meters per second. We know the angle to the horizontal, and he's going to aim at this insect. And we also know the horizontal distance here. It says show that the horizontal component of the velocity is about 1 meter per second. So really the first thing you want to do is draw that vector first. Now you can see I've drawn in green the two components, the vertical component and the horizontal component. And in this case, it says show that the initial horizontal component is about 1 meter per second. Now it says about, which means it wants you to calculate it, and it's probably going to round to 1 meter per second. That doesn't mean the actual answer is for sure 1 meter per second, but it'll give you an idea that you're on the right track. So if I want the horizontal component, that means I need to say, all right, compared to 70, this is my adjacent. This is my hypotenuse. So adjacent hypotenuse, I need to use cos. So I've written cos 70 degrees equals the adjacent, which is what I've called Vx, so the x component of the velocity, divided by the hypotenuse, which is 3.5 meters per second. And then I can move this around, and I get 1.2 meters per second. Now to ask for the vertical distance to the insect if the droplet hits it. Okay, so this is a projectile motion question, so I have to keep my horizontal and vertical information separate. Horizontally is going to be a constant speed, and vertical, suvat, I'm going to write this in right away so that I don't forget. And I'm also going to remember that the time can be the same in both sides. So Vx, V in the horizontal direction, we've just calculated that out, 1.2 meters per second. I know the distance here is 0.4 meters. Vertically, I'm looking for that one. Initially, well, yes, I could calculate that vertical component. I'm just going to write Vy for now. I don't know it, but remember, if the x component over here was 35 cos 70, that means my y component is going to be 3.5 sine 70. And I'll put that in my calculator later. And I know the acceleration due to gravity is going to be negative 9.81 meters per second squared. And, so you see, I've got two pieces of information, and I don't know the height, so I need one more piece. Now, you might be tempted to say, hey, v equals 0, but there's nowhere in the question that tells us that the water actually stops when it gets to the insect. And you might actually argue that that wouldn't be very effective then. If it reaches its peak right at the insect, it's not going to have any energy to knock it off the leaf. But, and there usually is a but, take a look right here on our horizontal motion. I know the horizontal speed and distance, so I can get the time it takes. If I know the time here, I can then put the time written down over here, and that will give me enough information. So let me start with that. Okay, so there's my equation for horizontal constant speed, and moved it around, put my values in, and I got 0.33 seconds. Now let's put that in over here, because the time is the same both horizontally and vertically. So now that says I need an equation that has S, U, A, and T. That's the one I need from my list. Now, I don't have a 0 here, so don't go canceling things out. Let me put in the numbers. Okay, so U, that is the initial vertical speed, 3.5 sine 70 times the time, 0.33 seconds, plus 1/2, and don't forget this is negative 9.81. That's important because it's actually in the opposite direction that it's moving, and time squared. And when I put it on my calculator, I'm going to get 0.55 meters. Stop and say to yourself, does that make sense? It's about half a meter off the ground or above the water? Yeah, that's about right. Now, it says sketch the path of the water droplet on the diagram above. Now, if you put the values in and actually try to calculate how high does it really go, you get something about the same height. In this case, I'd say that's kind of crazy, but if I want to draw this on here, what I should see is I should see a line that goes up like this, and I want to see that it's a parabola shape. Whether you had it like that or you had it up a little bit higher, I would have accepted either one of those. What I'm looking for is that you realize it's a parabola shape. Okay, for number 3, we've got this airplane, and it's one of those fancy ones that can take off and land vertically, so you don't need a runway. Those ones that are like on the marine ships. So we've got a lift fan thrust upwards, an engine thrust upwards, and the weight downwards. And for now, we're just going to ignore the fact that they're not happening through the exact same spot. Let me draw a free body diagram. So here are my arrows. We've got Fg, the force due to gravity or weight, pushing down. And we have the engine thrust upwards and the lift fan thrust upwards. Now, one of the issues right here is our arrows, because if it wasn't moving, or if it was moving at a constant speed, then I should have my down arrows equaling to the length of this arrow plus this one. And what I have now is I have definitely in the up direction, I have more magnitude of force than I do down. So technically, as I've drawn it right now, my airplane would actually accelerate upwards. Now it says given that the lift fan thrust, it's hard to say, is 68 kilonewtons, calculate the engine thrust in figure 3. Well, let's say that it is just hovering above the ground at the moment. That would mean that there is no acceleration up or down. Remember, that doesn't necessarily mean it's on the ground. In fact, I haven't drawn a normal force here. So if then I have 180 newtons down, oh, wrong thing. It's kilonewtons. That's a big deal, right? Kilonewtons means just like kilometers. It's this many newtons. And upwards, I have 68 kilonewtons. Now, if I use kilonewtons all the time, then my answer will be in kilonewtons. And so that means if I'm hovering, then that means all my forces are balanced. So that means the thrust must be the difference between the force due to gravity pulling down minus the up thrust here, and I'll get 112 kilonewtons. So as long as my engine is giving me 112 kilonewtons, I will have no acceleration up or down. It will just be able to hover. Now, part B says, after it's taken off vertically, the engine outlet, that's this one right here, is allowed to turn. So that means my thrust is no longer vertical. Describe the subsequent motion of the jet in horizontal and vertical directions. So in the horizontal direction, once I change those engines in the direction that we have the thrust, we will have a net force in the horizontal direction. And to start off with, it's only going to be from the engine. But as it goes faster and faster, we know that the air resistance is going to get greater and greater. And it's going to keep on increasing until the engine thrust and the air resistance are exactly the same. And at that point, we'll say that it's reached its maximum velocity in the horizontal direction. Now, at this point, we're going to assume, since it's only moving horizontally, that the upwards force and the downwards force, so in other words, vertically, those are going to be balanced the entire time. Okay, so let's move on to part C. The aircraft accelerates horizontally and it's reached its maximum velocity. At that point, the thrust from the jet is 55 kilonewtons. The weight of the craft is 180 kilonewtons. And we want to calculate the horizontal acceleration. Now, if you remember, our equation is F equals ma. And more importantly, this is the net force equals ma. Horizontally, I know that the only force I have at that point, or at the beginning, is the 155 kilonewtons. But one thing to point out is I need the mass, and a very common mistake is people putting in the value of 180. That's not the mass, it's the weight. Remember, everyday English thinks that the word weight means something measured in kilograms. But in physics, weight means something measured in newtons. It's a force, not a mass. So we've been calculating weight by force due to gravity equals the mass times the acceleration due to gravity. If I move that around, here we go. That's 180 kilonewtons. And remember, kilo means times 10 to the power 3s, or 1,000, over my 9.81. And this is going to give me 18349 kilograms. All right, so that's my mass. At the beginning, I've got my net force. So let's move our equation around. So A is going to be F net over the mass. That net force was 15500 over my mass, 18349, will give me rounded 8.4 meters per second squared. So this is the acceleration at the very beginning. Now this is the acceleration at the very beginning. Remember, when there was no air resistance. As it goes faster and faster, that means we're going to have a greater and greater amount of air resistance. Okay, so one of the things to remember is we're going to then have that net force get smaller and smaller till eventually our friction and the thrust from the engine are going to balance out and I have zero net force. Now, D says state and explain one characteristic of the aircraft that will limit its maximum horizontal velocity. Well, and this is the part where you'd be thinking about, well, how can I get it to go faster? Well, maybe you're going to tell me that the engine, if I had a better engine, maybe I could be creating a bigger thrust. So then I could have a bigger force, and so I'll be able to go faster and faster until I get the air resistance equaling the engine thrust. And so it would have a higher maximum velocity. Another thing you could be thinking about is the shape or how streamlined it is. This actually affects how the air resistance gets created. Remember, basically you're trying to push the air out of the way as you move through it. So if you had something that was more streamlined, or maybe the surface was smoother, then you would have less friction, and so you could go faster and faster before you get that same value that you're getting from your engine. Okay, so here's our helicopter. It's moving on an angle. Says it moves horizontally, okay? But it just means that right now you can see that the blades aren't parallel to the ground. So A is going to be the lift force that comes from the helicopter blades. That means, since it's on an angle, because that's coming perpendicular from the blades, part of that is going to be pointing straight up, and part of that is going to be moving it horizontally. Now, first part says name the forces B and C. Well, if I'm going to assume that the helicopter is in this position, we're going to assume that it's moving to the left. Therefore, the force that is going to be opposing it, B, that's going to be our air resistance. And then C, the one pointing straight down, that is our force due to gravity. Okay, so now parts B. The lift force, they gave us a value of 9.5 kilonewtons at the angle to the horizontal. Calculate the weight of the helicopter. Now, since it's moving horizontally, that means I have no acceleration in the vertical direction. And if there's no acceleration, that means the forces must be balanced. So that means this force due to gravity here must equal this component of the lift force. So if I'm looking for the vertical component, this one right here, remember this is like a rectangle. So compared to this triangle that has my angle of 74, this side here is going to be my opposite. And I have the value of this one here, which is my hypotenuse, 9.5 kilonewtons. So opposite hypotenuse, I'm going to need to use sine. Okay, so I wrote sine 74 equals A with the little v. That just stands for the vertical component of A. And you can write these things out in words. There's no rule to say you have to use this subscript or that, but it does need to be clear that I know that you know what you're doing. Okay, so here we have sine 74 is my opposite, which was the vertical component, divided by the hypotenuse, which is 9.5 kilonewtons. And so when I move that around, I'm going to get 9,132 newtons. And you'd probably round that to 9,100 newtons. And the reason I would say that is because this value here only has two significant figures, and same with this one. So my math can't make my units or my measurements more precise. Okay, so again, here we've got a skydiver falling down. He doesn't have his parachute yet, but it does say he's at terminal velocity, so hopefully he's about to pull it. So first part says name the forces X and Y. You can see there, force due to gravity or weight, that's what X is, and Y will be the air resistance. And part 2 says force Y acts upwards, and that's because we know the friction always is going to oppose our motion. Okay, it always works against, because it's basically us trying to push through the air or push through the water. Any fluid would be acceptable. Now, part B, when the skydiver first starts to fall, X and Y were unbalanced. Okay? And it says describe and explain the effect of the unbalanced forces on the skydiver. So, when we start off with the forces are unbalanced, and that means the skydiver is going to accelerate. And at the beginning, X, the force due to gravity, is going to be bigger than Y, the air resistance. In fact, if it's not moving yet, you don't have any air resistance. As the skydiver speeds up, though, we know that the air resistance is going to increase. So if the air resistance is going to increase, that means the net force, gravity minus the air resistance, is going to get smaller and smaller. That means the rate of the acceleration, the actual number, is going to go from 9.81 acceleration at the beginning to eventually zero, right? Because zero means that it's traveling at a constant speed. In this case, we call it terminal velocity. The speed is going to increase and increase until we get to that point where the two forces are balanced. So it's still speeding up until we finally have the two forces balanced and you reach terminal velocity. I hope this walkthrough helps you with the review questions and you'll be ready for your quiz on Monday.